Hello everyone, I Zaratala welcomes you all in the fourth day of this training based on machine learning algorithms. We hope you all are enjoying this training. And now I want to call Mr. Sabyasachi Kabiraj sir. Sir, over to you.
Yeah, good evening to all. Am I audible?
Yes, sir.
Okay, let me share my screen. Yeah, is it visible to all of you? Is it visible?
Yes, sir, visible.
So, yesterday, part of some of six machine learning algorithm, types of machine learning algorithm, and their parameters, and finally the accuracy and part, right? So, in this class, we'll see some case study related RF model, and then we'll see how digital training samples, and we will have a practical demonstration for it. Okay. So RF model, the full form of RF is random forest. All of you already know this, right? So this is a kind of supervised machine learning algorithm, and this is very popular and widely used, right? So we have selected this one as one of our practical demonstration. So straight away I will go to the Earth Engine. So who have like their account, they can directly follow me through this. Just I will log into my account and we'll start one by one. So if someone to do practice here itself, can open the code editor. And today I will show you the demonstration part. So I hope my screen is visible to all of you. The Earth Engine code editor.
Yes, sir, visible.
All of you know this particular interface. So we have explained this is the code editor interface inside the Earth Engine. And today we'll write some of the basics of code in a single class because we don't have time to explain you each and everything. But whatever possible, I will try to explain you. So you are already aware about the part where we are saving our script, and can create the documentation part, and third is asset. So here basically we are saying the different kind of save file and raster images, all the things we can save it here. Okay. So first of all, I will show you the interface, how it will work. So for example, I have a study area, so which is named as let me check where it is. Okay, which is named as ROIWB, right? So like this, it will come once you import. So how you will import? So you have to go to the new, click on this new, and there are 2 to 3 options will come. So if you want to upload an image, can this. So in this case, just I want to upload my shape file or area of interest as a shape file. Or if you have it is in CSV, you can upload in CSV. So in my case, I have in shape. So just I click over here, and something like this it will appear, right? And then we have to click on this select. And then you have to select the shape file that you want to analyze. So regional interest. So for example, I have for my work so something like this it will come. Okay. So remember, it's somewhat difficult if you see the extension written over here in the back side of the Earth Engine page. You can see the back side. So what are the extension it is asking? It is asking the SHP. It is asking if zip and DBF, PRSX, CPG, fix, and these are the format it is asking. So generally in our save file, we will have these are the extension. So 1, 2, 3, 4, 5, 6, 7. So here we can see 2 to 4, and then these are the things. So first one is .cpg. So .cpg, whether it is there in the list, we have to see. Yes, it is there in the list. So select this first. Okay. Then you have to see the next one. That is .dbf. That is database file. Okay. So whether that is also there, so you can see here it is there. So you have to click that also by pressing the control key in the keyboard. Okay. And then it is .prj file, which is projection file. So it is here. So that also we need to select it. The next one is QMD. Whether the QMD file extension is available over here, you can see we can't see it here. All right. So we have to skip it. The next is .shp. So which is a shape file. It will tell the geometry of the particular file. So .shp is there. Yes, the first one is .shp. So select that part. And then the next one is extension file .shx. So whether that is there, yeah, it is there. You can see. So that also you have to select. Now you can see except one file of this all shape file, all files, only one file is not get selected. That is .qm, which is not available in this. But if you miss one of this file, then your Earth Engine will give an error. So for example, now this 5 different types of file format I have selected, and if I click on open, and you can see there is no error, it has taken. Now I have to put the name alone. But in the case of, for example, I am selecting .shp, and then these are the things. If I select, okay, so if I forget one, and if I try to open it, so Earth Engine will give an error. File with names .cpg, .dbf, .prg, .shp have already been selected for the upload. Okay, so it is already selected for the upload. Okay, just cross it. Now this is a fresh selection. Just I will show you again. So just select and click OK. So you can see the .shp file must be accompanied by .dbf and .shx. So .shp file must be accompanied. So we have .shp and we have .dbf, but we are missing the shx file. So now we need to select the shx file as it is asking me. And now see, the error has removed. And after that, you need to name it, the particular region of interest. So in my case, I have named it as a ROIWB. Okay, and just click on upload. Once you click on upload button, it will populate in the taskbar in this. Okay, and once the task will get finished, it will generate a tick mark in the right corner of that file, and after that you can see that file in the assets option. So if you're not able to see, you have to refresh it over here through this refresh option. We click it, it will take some time, and then it will refresh and give you the latest files, right? So likewise, you can first upload your region of interest where you want to do your analysis. Okay, I hope this part is clear. Now my region of interest we have uploaded through this. The second thing is, once my region of interest is uploaded, I want to visualize that, right? Whether that is uploaded here, whether it is supporting properly, it is adding to the layout or not. So that I want to see, right? So for example, this is my file, and if you see here, just click on this. It will take some time to load. Okay, so you can see here is our location, and that is shown in zoom view, and what are the properties are there, that is also written. So the detail attribute will present over here. So that means it is perfectly uploaded. Now I want to visualize in the map. So first of all, to visualize, I need to bring it, that particular save file, into the script section of the code editor, right? So what we have to do? Here we have three icons. So the first icon is share. So if you click on share, what it is asking? Add access. So if you want to give someone access to this file, just put the email of that particular person, and then you have to assign whether he can edit the file or only he can read the file, and then we have to give access, like add access. Or if you have some app and you want to give to that particular app to access this file, you can name that particular app. So here I have two apps. If I want to give the access to that particular app, you have to select this and add app access. So likewise, we can give access. And then user with access to this asset can view it in the code editor via this link. So if you share this also, anyone can see that through this link. Just you have to copy it, right? So this is the first option. What is the second option? The second option is to rename the file name. So if you click on this, you can see I can rename it, right? Region of interest, this also I can make. Okay, that is the second option. The third option is import into a script. So if you click in this, Earth Engine will import that particular file to the script, right? Now it is by default taking variable as a table. Okay, so you can change the table and you can put as a AOI, area of interest, right? Now my variable name has changed. Now I want to see this particular region of interest where it is located. So how will you see? So I need to add this particular variable to the map. So to add a variable into map, the command is map.add layer. Remember, it is case sensitive because it's a JavaScript and it is a case sensitive. So in map, the first M will be in caps and remaining all will be in small. In add layer, we will have L as a cap, then remaining things will be in small. And if you don't know the proper syntax, you can go here and just add map, map dot add layer, and you need to search where it is. So it is here. So you can see the syntax written over here. So what it is saying? So it is saying to me map.add layer, and inside that you have to put the first object which you want to map, and then visualization parameter detail. So this is particularly the minimum, maximum, or the color, and then name it, and then shown, then opacity, actually the transparency of the layer. So if you want to go into the detail things also here it is present. Okay, so by default the object is the compulsory one and remaining and all are optional. You can see here EE object, we have to put a collection, feature, image, or raw map ID, whatever it is we have to give. But the remaining and all, you can see there is a option there, all our things are optional. You can see all the things are optional. So if you have values to this particular variable, or you can say particular object or particular name, you can put that, otherwise leave it. Okay, so now I am adding. So you can see if you put control and space, just click control and I will do control and space. Okay, now these are the things is optional, so I don't need this. Only I need is EE object, and that will be able to see in my map. So once you finish this comment, just you see is there any error. So if it is having some error, it will show in this side, left side of the Earth Engine. So for example, I'll remove, you can see there is a missing semicolon. So it is saying me to add a semicolon over here. So I will add that, and you can see that is vanished, right? And now if I run that, you can see there is a layer added here, which is made this. So it depends on the internet speed. As my internet is slow, so it is taking some time. So you can see it looks something like this. And this is called map view of Google base map, and we have satellite image, satellite view as well. So just select on satellite, you will get a satellite, right? And both do this. Just untick, it will disappear. And this is the opacity, you can see. So these are the features are available in Earth Engine by default. Okay, so now this is my study area. Now I want satellite image for this particular study area, right? So I want to do analysis using Sentinel-2. So it will take some time if you have good internet speed response. So you can see the Sentinel-2, Sentinel-5, Sentinel-5P. We have to find out which is Sentinel-2. You can see here Sentinel-2. This is also Sentinel-2. This is also Sentinel-2. So these are the Sentinel-2 products are available. So if we take the first one, so what it is saying, the product is available after 2017 to till now, right? And the band details are here. Image properties are here. And terms of use, you can go to the European Space Agency website if you want to see. So in description, if you want to read it, the detail how the product they have generated, so those details will be here. Those things you can read it. And now directly I want to import it. So there is option called import. So just click on the import. And you can see your entire image collection is imported over here. Okay. Now this image collection, I will rename it as a S2. Sentinel-2, which is having 23 bands. Now, if we want to see the detail here, also the detail will be available. So band 23, you can see the all bands over here, and it's unsigned integer 16, and the properties. So the detail of the Sentinel-2. Okay. And you can see the visualization maximum value, then minimum value. Those things also will be there. Okay. So now we got our satellite product. Now the next thing is we need to filter it by date, right? Now we have the entire image collection. So if we print it, what it will show, so you can see is the collection query aborted after accumulating 5,000 elements. So after 5,000 seen, it is giving an error, right? So the number of image collection is more than 5,000 with the entire image collection, which is started from 2017, right? So you can see this is 2017. And then, so now we need to see the detail of the product. So here we can see the view data sets in the catalog option. So here we have the detailed information about the product with the code given over here, right? So they have given the code where they have filtered the cloud pixel as well. And there is an option called open in code editor. If we click in this, so we can see the detailed code of that particular product, right? So what the thing is, this is the multiple comment. So it's starting by slash and then double star and then ending by like this. So this is a multi comment. So by default, if you are writing like this, it won't consider as a script. And this is a particular one comment, one line comment, you can see by double slash. So this also won't consider for to run the script, right? So these are not comes under the script. This is for writing the detail about the script. So the first one is function to mask the cloud using Sentinel-2 QA band. So they are using the QA band to mask the cloud. So for that, they have created a function called mask to clouds, and they are renaming it as an image, and they are putting a dictionary over here. You can see, and inside the dictionary, they have different variables, and finally we are getting a mask-free image, cloud-free image. And after that, even though we are filtering it again, right? Because here we are directly taking the image collection. This particular comment comes from here. So here is the command to call all the image collection of belongs to this particular Sentinel-2. So we have to select this one, and it will copy the entire code of this. So here is that if you click on this, it will get copied. And if you see, this only they have copied over here, from here to here. And now they are doing a filtering of date using dot filter date. So if someone don't know what is dot filter date, can search over here dot filter date, and it will give you the detailed explanation about this particular command. So where it is dot filter date, right? So here it is, filter date is the starting and ending date. For a feature collection, for image collection also it is same. So in the both the cases it is same. So our case, we are running the code with image collection. So we have to say this also, this only. So what it is suggesting, give me a starting point and give me a ending point. Okay. So we have given the starting date as 1st January, and the ending date is 30 January, right? So likewise, we have to filter our satellite image. Okay. Now the pre-filtering to get less cloudy pixels, or you can say granules or tiles, whatever it is. So this is a particular command to filter out the cloudy pixels. So cloudy pixel percentage less than 20%. So you can see e dot filter dot ee filter dot lt, which is less than. So in my previous class, I have shown to you GT greater than 0.5 threshold value. Now here it is LT, that is less than. Okay. So less than 20%. Take this and do that particular satellite image and do masking. So how it will do masking? Using this function. So where it is? It is already we have created over here. So using this mask function, it will mask the particular cloud pixel. Okay. Now this particular thing is clear to get the proper image or clear image. Now the next part is visualization part. So now we have taken the less cloud pixel images, not only images, because we have given a date range. So within this date range, we will have multiple images. Now we are collecting an image collection. So it is a data sets of many images. So that is image collections. So still we didn't select single image. Okay. We only selected the less cloudy satellite images of Sentinel-2. Now here you can see S2SR product we have selected, that is surface reflectance product, which is much more accurate because it is already pre-processed image. So we don't need to require much pre-processing. So this itself more than enough to do any kind of analysis. Even some kind you will get more cloudy in some places like hilly area or coastal area. Those cloudy pixels we can't remove it because we won't get clear image for that particular place, because all over the year you will get cloud, so you won't get cloud free images. So in those reason it is very difficult to get, but 99% cases you will get it. So now coming to the visualization part. Okay. So how to visualize the data? So we have created a variable called visualizations, and in that we have created a dictionary. So basically dictionary will be in curly bracket. Okay. So this is a dictionary where we are mentioning the minimum maximum value, and we are telling the bands. So what are the bands? So if you see this one, so within this bracket, this is actually list, and this curly bracket is a dictionary. So inside a dictionary, we are putting a list of band name. Okay. So what are the band we are listing? Band 4, band 3, and band 2. These are the 3 band we are selecting. Now the next one is map.setCenter. So what is this? So this particular command is generally used to set the center view while running the script. So once you run the script, it will go into that particular lat long value with a zoom level of 12. So I have shown in my previous classes, if you have noticed that the maximum zoom is 20, but here you can see they have used only 12. So it will go at the zoom level of 12 in this lat long. Okay. So first of all, we will do this in our region of interest. So see, we have region of interest here. So if you want to use this script, what we will do, we'll close this first one, and directly we'll import our study area. Here we have our study area, and we'll click in this, and you can see it is imported in the script, and I will name it as a AOI. Okay. Now I don't know the particular lat long or of that particular AOI. Okay. So I don't know where this AOI located and its lat long. So what I will do, first I will print it. So here I will print, anywhere you can print it. So before starting the script itself, here I can print it. So no need to print. Map dot add layer also you can do, layer, and then we will put AOI and just run the command. So this command is for only to check the lat long. So how to check the lat long? So you just run the script, and it is located somewhere in India. It's here. So this is my study area, right? And now I want to find out the lat long of this particular place. So we have a tool called inspector over here. So you'll click on this inspector and click wherever you want. So I'm clicking in the middle. So just click in the middle. So you will get the lat long, you can see here. And with the lat long, you will get the zoom level also, we have seen. So here, what is the zoom level? So zoom level is 10. So if you keep like this, your zoom level is 10. Okay. So I'm copying this and I will paste it here. I'm not changing the zoom level. I'm keeping as a 12. Okay. And now okay, and now I am running the script. So up to this we have finished the visualization part, and then we have finished the dot center, set center, and after that you can see map.add layer, which I have already added for my feature layer also. So now I don't want this one. So map.add layer I have given, and the data set we already know that is belongs to this variable. And finally we are telling dot mean. Why dot mean? So as I already told you that there will be 20 to 30 satellite image within this date range, and what this dot mean will do, it will create a mean value of the selected images. Selected image in the sense this filtered images. So we are filtering continuously. The one filter is date, the second filter is the cloudy percentage, and the third filter is mass cloud. So these three filtering process we have for pre-processing, right? And after filtering that, whatever images will come, let's say 20 or 30, so it will take the mean value of that all image collections or images, and it will visualize. So we'll see how it looks like. So I'm just running it, and it is going into that at the zoom level of 12. So we can see our satellite image of Sentinel-2. So this is Sentinel-2 view. So you can see there is RGB, right? So these are the cloudy pixel where you can see white. These are the cloudy pixel with less than 20 we have given. So let's have a look with less than 10. So if we put less than 10, and then we'll see whether the image is coming clear or not. So even though this area is not clear, but my study region is clear only. So this is the way to visualize a satellite image. Okay. Now my satellite image is ready. Now what is the issue we are facing? The issue is, while visualizing the satellite image, it is visualizing the entire other unnecessary region as well, right? So I want to see only my study region, not the other region, right? So generally in GIS, we have a clip tool to clip a particular portion of a satellite image or particular portion of a vector file, whatever it is. The tool name was dot clip. So what we will do, we'll try to clip our satellite images. Okay. So in Earth Engine also we have that function and with same name. So first of all, we need to create another variable called dataset mean, and we'll call dataset dot mean. Okay, so what exactly it will do? So it will create a mean value of all the dataset, which it was doing previously here in map.add layer. Now it is doing in this stage itself. Okay. Now the second thing is, I will create a variable called clip AOI, that is area of interest, and then I will create data set mean. So I am taking this particular variable, right? And then I am trying to clip it. So in Earth Engine also the tool name is clip, and which area I want to clip? My region of interest. So my region of interest, what is that? My region of interest, that is AOI. So just select that particular name and just paste it over here. Remember, syntax error is a big error in JavaScript actually, as it is a case sensitive programming language. Okay. So now we will try to visualize this clip AOI. Clip AOI. Okay. So now if you run the script, so we can see our region of interest alone, not other area, right? Yeah, very simple. Again, I am repeating. If someone is stucking somewhere, I will repeat the same again. Okay, so the entire code is already we have taken from the data catalog window of Earth Engine, where the pre-processing technique was already there. So I have not written any code, only I have added 2 to 3 code, 2 to 3 line code, right? Other things were already there. So if you want to change your date, you can change the date range if you want, or if you want to change the cloud pixel percentage, that also you can change it from here, or you want to change the band combinations. So here you can see the true color image, and if someone want to see the false color image, they can change the band combination by 8, 4 and 3, and this RGB will become false color composite image, FCC, and if you run it, so you can see a false color image. So that's all. So that's the thing. It's very simple. You can see the false color image of that particular region. Okay, I hope there is no doubt till now. So now we got our satellite image. Now what we want? we want our data sets or training samples now. Okay, so first of all, our objective supposed to be clear. So what we want to classify, first of all, that I need to be clear, very clear. Now here in this case, if you want to classify land use and land cover, so you'll have various features in this. So first of all, I will go to the city region. So this is the city. You can see the built up areas. These are the built up regions, and if you see, these are the industrial region. Then we have water bodies, small ponds, right? And then this is built up area. This is somewhat runway, and these are some of the mining areas. You can see these are the mining areas. So it's a diverse region actually. These are the mining region, you can see, right? So first of all, I will show you the first thing which I have not shown you till now. So that is just print this data set. Right? And so now I need to collect the training samples of this. So this also still it is showing, not here. So now I need to collect training samples. So first of all, my objective need to be clear. So we are clear that we will try to find out the water body and land. These two things we will try to find out, whether the particular thing is belongs to land or water body. But if you want to be in more complicated way, we want forest region. So you can see the forest patches over here. So these are dense forest regions. You can see. So if you want that way, then we have to take more number of training samples, right? We have to take more number of training samples. So first of all, I will tell you how to draw it, training samples, okay? So as I already explained in my previous class, how to draw a particular feature. So using this tool, so we have a tool called point, line, polygon, and then rectangle, okay? So just zoom it. For example, I will zoom it over here. And then I want to draw a polygon over this forest region. So I will just select the draw a polygon and see it is generating a geometry, and I will click on this setting icon and I will put as a forest. Okay. So since I will take lot of samples in this region, so it won't be a geometry or a feature, it will be a feature collection because it's a more than a polygon. So we will take multiple polygons. So it's a feature collection. So you have to click on feature collection. So now we have clicked on feature collection. So this forest will become a feature collection. Now what particular like what property you want to save? So I want to save it as a LULC or land use land cover, and the value we can start from 0 because in all programming languages you can see that value will start from 0. So 0, 1, 2, 3, 4 like that it will go, keeps on go. So like this only it will work. So now why I am writing this property? Because based on this property only our entire algorithm will run. Okay. So now I'm clicking OK. So you can see now this is forest, and inside the forest, so you can see the value is disappearing, right? If I put 0. So now if you put 0, the value will automatically disappear because computer doesn't know because we are not writing a script. Then what you have to do, just put 1 and just click it over here and see again. Now you can see there is 1, right? So while doing the classification, we need to remap this again. This 1 we need to remap to 0, and then we need to classify the image. Okay, so now first of all we'll take the samples. So how you will take? So you can see the forest is already selected and the polygon also selected. Now zoom into it in the forest region and just draw a polygon. Okay, so red and red is not visible, so I will change the color into green. Okay, so now it is green. So now I think you can see the forest region. Okay, so I've taken one sample here, one sample here. So we should take the pure pixel. There should not be any impure pixel. And if you do that way, then your forest can be a cropland area as well. So you have to be very careful. So you can see this forest is very pure and dense forest. Maybe in your case, it won't be like this. So what you have to do, in some cases, you have to zoom into it. So just zoom and zoom, keep on zooming it and take that particular region alone. So for example, these areas, trees are not available. So you have to avoid these areas and take these areas alone, right? So this training sample collection is a very big task. So you have to spend some time on this because entire model depends on this training sample only. Okay. Like this, you have to collect. So likewise, we need to collect training sample, and each classes we need to take more than 50 or more than 35. Okay, so that our number of samples will have more number. Okay, so we need at least 50 to 60 total number of samples. So to divide into 70 and 30 into training and testing samples, so we need at least 30 to 40 samples in each class. So now I have created forest. Same way I need to create for built up, industry, mines, like that I need to create water body. And then we need to keep on take the training sample. So we have to take that way. So I am not going into this further. Okay, I will directly come to the machine learning. So I have already this training samples created over here. So I will show you that particular part. So it's there. So here I have saved the script. So you can see all the samples are present over here. Okay. So you can see the samples. Somewhere I've taken point data, somewhere polygon, and likewise we need to, you can see the forest areas I have taken like this. Okay, so once you will do like that, so you can see the first one is West Bengal. So if I select on this WB, so here I have 0. Actually I put 0, so it didn't work. Okay, so after that we have started with this vegetation. Then this one is SD scrubland, maybe SD belongs to sand deposit. Okay, this is for sand of this river. And then industrial zone, then cropland built up like that, it is classified. So you have to change the color accordingly. So here built up and this color is same, so I will change it into yellow. Okay, so you can see the color is changed to yellow, and this is a sand deposit. Okay, so likewise you need to take the training samples of each class, and while taking the training sample, don't forget to change this value. So each time you are changing, you need to increase 1. So here in this case, vegetation belongs to 1, value 1. And also don't forget to make this as a same. So this property should be same. And if you are putting L as a caps and then C as a small, then it will not able to take the inputs while running the algorithm. Okay. So here you can see sand deposit, the value is 3. So all values will be unique of each class. So just keep these things in mind. Okay. Now, so once you take the training samples, your variables or training samples will come something like this. And each classes, how many samples you have taken, those things will be appear over here. So you can see water body, WB water body is 14, vegetation 35, likewise it will come. Okay. And these things already you are aware about this, right? Only you are not aware about this filter bounds. So what it will do, the filter bound will try to filter out all the unnecessary satellite images, and it will try to filter it within the boundary of ROI, region of interest. Okay. So what is the difference between filter bound and clip? You may have question. So filter bound basically take the images and it won't clip according to your ROI. But clip is like it will work according to the shape you have defined in ROI. That way it will take. So that's the difference actually. So these things also you are aware about this visualization parameter. And you can see after that we have clipped the ROI, and here instead of mean I have taken the median. So this is also you are aware about this. And come to the next part. Okay. And map.center also you are aware. So these things already you have finished it. And now the main thing is starting from here. So this particular thing is merging all training samples into one. Okay. So what it is doing, whatever training samples you have taken, just dot merge, and within a parenthesis you need to write the particular variable name or particular feature name or feature collection name, and thus it will merge it with all this into one with the name of the variable TS, total sample. Okay, right? Total sample. So once you print it, the number of total sample will appear. Okay, this is the function of print. So whatever property is there, that will print it. Okay, the next one is variable we have distributed randomly, so that is called random column. So this is a distribution of samples into random manner. So randomly it will be distributed. So that is random column. So if you see, if you are not understanding that, just put random and then column C is caps. So you can see here. So in case of image collection and the case of feature collection, so we are working with features, so we need to see the feature collection. So here what it is doing, so adds a column determinant pseudo random number to a collection, and then the uniform distribution by default output, and outputs are in range of 0 and 1 using normal distribution. Output have, so these are the things, and the input collection to which add a random column. So we have to put the feature collection to that particular thing, and then we have a string, then we have a long, and likewise we have a long list. But here we are putting feature collection as a TS, so here the feature collection is there already, so our feature collection is TS, and then we are already distributed this all training sample into a random sample, and after that we are dividing this total sample into two different sets of data, right? So one is training sample and another is test sample. So how it will separate? So we are putting a logic behind this. So what is the logic? So take the random sample and filter it. How you will filter? Filter it with less than 70% of the sample as a training sample, and whatever remaining sample that will be greater than equal to 70, so remaining 30, that means remaining 30, or you can put 03 as well. Okay, if you have to put equal to, and thus it will divide the entire sample collection into 70/30. Okay, and now if you try to print it, it will show you the actual number. So here we will get the total number, and here we will get the training and test sample number. So the total number and this two number should be same. So if we see that, first of all, we see this, just click on run. And number of objective is something around 137, right? So which belongs to the total. And now if I want to print these two also, so if you combine these two, 97 plus 40, so total number will come to 137. So this should be same. Okay, and now what are the properties are there? You have to check the property. So we have LULC only, and the type is integer. So the same way here also, if you see LULC, the same name is matching and type is integer. So it is randomly distributed. You can see there is a column included as random. So this way it will work. Now we got how to separate our entire training sets into test and training sample. So this is for 70% of the total sample collection, and this is 30% of the total sample collection. Okay, so now we have separated it. Now the final thing is how to train the model. Now we have defined the training sample, we have defined the testing sample. Okay, so to train a particular model, we need training sample, and what else we need? We need the algorithm, and before that we need a property. Where is the property? Based on what we will tell that particular image collection or particular predictor that based on this parameter you predict this or that. So we need that parameter also. So still we have not defined the parameter, only we have defined the satellite image, and that also we have not added into the model. So now the next step is to add that particular parameters, and before that we need to train it based on the satellite image or the parameter. So inside S2, that is Sentinel-2, the entire image collections are there. So here is the Sentinel-2 where it is taking the entire data set median value. So that means the entire bands of Sentinel-2 is involved in this, right? And this particular sample region code, what it will do, it will overlay with this particular training sample, and it will try to get some kinds of information about this LULC and this band. So if LULC is built up, then what are the different value of this band? If LULC is some kind of water body, then what are the different values in this image collections band or Sentinel-2 band? So that is the particular function of this sample regions. So if you try to see, it's an overlay function and sample regions. So here you can see. So basically what it will do, it converts each pixel of an image that interact one or more region to a feature, returning them a feature collection. Each output feature will have one property per band. So one property per band of the input image, as well as any specific property copied from the input features. So whatever you will give in this training sample, it will take particular value of each and every band and it will assign to the training sample, right? So that is the work of this sample regions. Now the next one is classifier. So which here till now we have not tell that this particular algorithm will work out or will define this particular algorithm. We have not decided yet. Now we are only playing with the overlaying things and getting the information from the satellite image for this particular land use land cover. Till now we have not defined our algorithm. Now we have to define our algorithm or call classifier. So we have the classifier code over here, and we're creating a variable called classifier, and in that classifier we are telling the that we are going to work with the random forest. So this is the particular code for random forest. So if you search over here random forest simply, so you will get this code ee classifier dot smile random forest. So that only we have written over here, and this 20 is a value. This value is number of trees. So here we have n number of parameters. These are called model parameters. Okay, we have parameters as a predictors. These are parameter inside the algorithm. Okay, so this algorithm output will depend on this particular parameters, and also the predictors which we are giving as a band 1, band 2, band 3, those satellite bands. So there are two main things which we have to work which we have to work on. Okay, so now here if you look, there are number of trees and the variable per split, then min leaf population, bud fraction, then maximum nodes and seed. So each parameter, or you can say details, are there in this doc provided by Earth Engine developer. So for detail you can go in this and read it and you will understand. I hope if you are not understanding, Google it, you will try able to understand. It's very simple. So if you see in this all parameter, there is something called default, right? Default, except this number of trees. So this is a very important parameters which we must need to give or we should give, otherwise the model won't work. So because of that, I have given 20. So I have assumed that 20 number of trees will give a better result, but I don't know what is the exact number which will give you best output. That I don't know. Okay, but I am assuming. And then I am training the model again using that training. So where it is here. And then what we are going to predict? The LULC, whether it belongs to 0, 1, 2, 3, 4, that we are going to predict. So what is this dot train? So if you search dot train, and you can see the detail over here. For a classifier, we need to find out here. For a cluster, it is here. So we are dealing with the classifier. So we need to go here. Okay. So if you click here, you can see it is asking me the features. It is asking the class property. It is asking the input property, subsampling seed. So these are the information we need to give, right? But among all the information, if you see, here it is given default value, here also it is given default, here is default, but there is no default value for these three. So we need to give these three at least to run the model. So I have given these three things at least to run the model. What are the three things? So first one is the training, the second one is the predictor which you are going to predict, and the third one is the input properties. Okay. So features is belongs to the training, and then class property is LULC, the input property is Sentinel-2. So likewise it will work. And then finally we are adding dot band names. So what it will do generally, it will take, actually this is added with this. So Sentinel-2 dot band names. So what it will do, it will take all the bands is there inside the S2. So that's why we're adding dot band names. If you don't add, it won't take. So that's why you have to add the band names. Okay. So I think up to this you have understood. Now we have decided our classifier. The next step is to classify the image. Now this is the code for classifying an image. Now I am telling this is the classifier and this is classified. That means my work will get over after this command. So what we will do? We'll take the Sentinel-2 and we'll tell classify, and then we'll tell the classifier. So what is this classifier? This classifier belongs to all these codes. So it will take all these things. Okay. And then it will take this S2 because S2 is our data set. And if you see dot classify, what is this? Dot classify, what it is doing. So for image collection, classify is we have to mention the classifier and the output name. Okay. So if you click in this, so you can see we have to give the image at first, right? Which is not mentioned in this. So for detail, you should always look into this. By clicking this, you have to go into that detail. So in detail, you can see there is a thing called image. So we need to give the image, otherwise it won't take. So we have to give the image and then we have to give the classifier. And then this is by default. It will take as a classification. And if you want to do some kind of regression, so you have to change into regression. So that is different part. So here we are working with the classification. So we have given the image and we have given the classifier. So this classifier belongs to Smile Random Forest. So now our image is classified. So classification process is got over. I want to see or I want to visualize what is the output. So what is the process? As I already informed you that we need to put a comment or write a comment that map.add layer, and this is the particular thing we need to show. So we need to put this and need to create a dictionary inside where we need to put the minimum and maximum value So what is this minimum and maximum? Is the band or is the classification, number of classifications, or you can say land is land cover classes. So you can see 1, 2, 3, 4, 5, 6. So we have given, actually it is 7. 1, 2, 3, 4, 5, 6. 6 is there, but here we have given 6. So we need to see whether 0 is there. Yes, 0, and then we have 1, and then we have 3 over here. Okay, 4, 5, 2. So up to 5 it is there. So just put 5. So remember, always you need to check this numbering. If it is a mismatch, then the output will come in different way, like color will change. So always check this. Okay. So now once you finish with this, you have to mention this. So now you can see I mentioned the 0 is the minimum and maximum is 5. So this will help in visualization. Now palette, what palette will do, it will create a list of color. It is depends on the user, which color the user want to select. So it's starting from 0 to 5. So the first one is water body, so I put blue, and the second one is vegetation, or maybe vegetation is in different way. Okay, whatever it is. So 5 colors supposed to be there. Okay, so 1, 2, 3, 4, 5, 6. So 6 is coming, so I need to remove 1. So I'll remove 1. Okay, so we have given a list of color, and after that we are closing the bracket, both the bracket, and this is for renaming the layer. That classified will get renamed into LULC RF, which will visualize over here. So now we'll see whether our classification working or not. So after that, we need to click on run, and it will take some time. So you can see LULC RF is taken. So we have renamed that. We renamed that LULC RF, right? So you can see the water bodies is appeared in blue color. Okay, so here also some water bodies, because of mines, you can see here also water bodies, right? So water bodies are coming perfectly, and the forest region have separate color. You can see these are the forest patches which we have sampled, so this also coming perfectly. And this yellow color, actually the built up region, which is somewhere it is giving error, so there will be the color mismatch or something like this. We have to see to put different colors. So first is blue. Okay, the second is vegetation. No, one, this is vegetation. Okay, put green. Change the colors accordingly. So 0, then 1, then 2 is, I think the last one, 2. Yeah, it's built up. So built up, we can put yellow. Okay, and then third one is, okay, sand deposition, so we can put as a black. And then industry is 4. 1, 2, 3, 4, 5, 6. Actually we have 6 element, and we need to have 6 color. 1, 2, 3, 4, 5, 6. We need to have 6 color. And then last one is put some kind of orange. Okay, So blue, green, red, yellow, black, orange, something like this. And so you'll get some kind of result, something like this. You can change the see now the forest area coming as a green, water body blue, and likewise you can see the sand deposition is in black color along the river. So this is a mining region where we have water. So if you want to see that, so you can see this area belongs to water body, and it has, and these are the sand area. You can see sandy region. So there will be more or less accurate, and you have to, after that you have to do the accuracy assessment, which will take time, and it is a big process. Okay, so you can see the remaining part for accuracy assessment. Okay, so that's all for today's class. We'll wind up today's class. Okay, if any questions are there, you can ask. Yes, Ajay, are you there?
Yes, sir. The first
Yeah,
question
my
is from
class is
Umesh.
today's class is over. Session is open for question answer.
Yes, yes. Yes, sir. The first question is from Umesh Kotegan, and he wants to know that which algorithm is good for crop classification.
Crop classification, there are multiple algorithm you can use. You can use support vector machine, you can use random forest. These are the two standard version through which you can get a proper result. Yeah, next. Your voice is not audible, Ajay. Okay, then how to add app, sir? So there is an option called app inside the Earth Engine, and if you click there, it will ask you the detail. You just put the detail and it will generate an app for you. Sir, is all Sentinel-2 data of 2A, 2C harmonized or have difference? Yes, there is a difference in pre-processing and post-processing. So you have to go into the detail for detail informations. How did you go about creating the training sample and import? So to create a training sample, I have shown you there is an option in the Earth Engine code editor itself. Select the polygon and then start creating polygons, and then rename it. Inside that you go to the property, and then property you put LULC and put the number of that particular land cover. So likewise you need to collect the training samples, or if you want to import directly you can import it, but in the same way you have to write it in the attributes. For example, if you're using ArcGIS, you just take the training samples over there, and remember that the proper attributes supposed to be there. For example, land class values supposed to be there, not names. So you always remember that computer does not understand the names, it is only understanding the value. So if you put built up or you put water body, it won't understand. So you have to put, instead of built up, you put one, water body instead of water body you have to put two. So the numbering only will work over here. Okay, and then okay, that's all. Is there any other
one more question, sir?
Yeah.
What is QA band?
QA band. If for this QA band, it's a quality band created by the Google developer. It is not there in the normally downloaded image from Earth Explorer, and that is particularly used for cloud masking. And for detail, you can go into the data catalog part of Google Earth Engine. You will get the detail.
Sir, the next question is, can the training sample template be created on GE, Google Earth Engine?
Can the training sample template can be created on GE? Yes, I have created in GE only. It is possible. See, if you digitize the polygon of training sample, then through asset option, there is an import option in asset. I have showed you how to upload a shape file. So likewise, you have to upload and directly upload that, and it will get uploaded inside the asset, and then you have to import through import option. Okay, that's all. And in that case, dot add merge will not come. Okay, because we no need to merge within a single file, all the things will be there. Okay, no need to merge.
Yes, sir. Thank you, sir. We have taken all the questions. Now we can end this session.
Okay, thank you.
Yeah, thank you, sir.